complex number is, so algebra we start with complex number. So complex number start with I. Complex number, it is of the form z is equal to a plus ib. I is root over minus 1, and it is, if we say 2 plus 3i, then 2 is real part, and coefficient of I, when it is multiplied with I, this we say complex part. So 3 is complex part, so we say A is real z and B is imaginary z. And our addition, subtraction, product, these are like this. So A plus IB, C plus ID, we are adding it. So Z1 plus Z2, in place of Z1 we are writing A plus IB, in place of Z2 we are writing C plus ID. When we add it, then real part goes to real part. So A plus C, A plus A minus B. Sorry, this is wrongly written. Just do it. Just do it. It is A is just do it. It is A plus real and real. So A plus, this is C. So actually it is A plus C, it is the real part, plus I, then B plus D. Similarly, this is also A minus C, then plus I into B minus D. Then product is, we take the product, so AC plus IBC plus IAD plus I square BD. And because I square is equal to minus 1, I square is minus 1. So root over minus 1 into root over minus 1, it is minus 1. So we write AC. So this becomes real now. So it is AC minus BD. So this I square is minus 1. This is minus 1. And plus I into BC plus AD. So what we are having, yes, so here real part is AC minus BD and imaginary part is BC plus AD. So when we go on multiplying I, it is I square is minus 1, I cube is minus I to the power 4 is 1, etc. Z bar is conjugate. So conjugate is Z equal to A plus IB and conjugate is Z bar. So real part is same, imaginary part we change the sign, we say this is conjugate. So when we take the product Z into Z bar, it is A plus IB into A minus IB. It is A square minus I square B square is equal to, in place of I square we again write minus 1, this becomes real. So it is A square plus B square. So what we are having, it is Z bar is equal to A square plus B square. And Argand plan. So Argand plan, so every real number, when we say a real number, so we can draw this line, mark this as 0, and we can plot this points. If it is 1, this is 2, then this will be to the left, it is minus 1, this is minus 2. So any point here represents a real number. So Argand plan is representation of complex number. So as we are plotting real numbers on a line, we can plot complex number on a plane. So if this is the plane, this is the plane. Plane means this is any point on a plane. If it is any point on a plane, we can, with reference to this one, we can have some location. So here we write this is a real line, this is real line, and this is imaginary, imaginary or complex. So when we say a plus ib, so a goes along real line, real part goes along real line, and imaginary part goes along imaginary line. So if it is a and if it is b, then this point will be a plus ib. So this is representation of complex number on a plane, and this plane is called Argand plane. Now if we say this as this is a plus ib, if we draw this, we join this point to this origin, then this, suppose this value is r and it makes some angle, this theta, then a is equal to r cos theta and b is equal to r sin theta. It is right angle triangle, so r cos theta is a and r sin theta is b. So we write this r cos theta plus I r sin theta, and z is equal to r, take it common, this is cos theta plus I sin theta. So this is called polar form of complex number. So r is root over a square plus b square, and it is called modulus of z, and theta is the angle made by this with real line, and this is argument of z. So mod z is this one, arg z is this. So this is from polar form. So square root of complex number, square root of complex number is a plus ib. If square root is x plus iy, then a plus ib is square of x plus iy, and after making square we have x square minus y square is equal to I into 2xy. So real part is a, imaginary part is b. Compare this one, and we have x square plus y square is root over a square plus b square. Then cube root of unity. Cube root of unity is 1. This is cube root of unity. So if it is x, then x cube equal to 1. So this is an equation, x minus 1 into x square plus x plus 1 equal to 0. Then we have x minus 1 equal to 0 and x square plus x plus 1 equal to 0. And after solving this, we will have x equal to 1 or x is equal to this quadratic equation, solution of quadratic equation, and we get minus half plus I into root 3 by 2 and minus half minus I into root 3 by 2. So we say one is omega and the other is omega bar, because this is real part is same, imaginary part changes the sign. So square root of x cube equal to 1 are 1 omega omega bar. And what you see, if we square omega, then omega square is equal to omega bar. So one is the square of the other, or we can have omega bar square is equal to omega. And because omega is solution of x square plus x plus 1 equal to 0, so if we write in place of x omega, we will have omega square plus omega plus 1 equal to 0. And what we have, omega square is equal to omega bar, omega is omega, then 1 is cube root of 1. So these three, sum of this, so all are cube roots here. So it is, sum is 0. And with this is the theory part. This is the things you need to know, and we can solve it. These are the problems. there are problems you can solve. I to the power 34, because I to the power 4 is 1, so I to the power 4 whole to the power 8, this is 1 again, remains I square, and I square is minus 1, so it is the answer. So this is the way we need to solve the problems. Then root over, suppose it is not written in terms of I, but because it is minus here, so we write as minus 1 into 81. So minus 1 is root over minus 1 is I, and 81 root over is 9. Similarly, this is minus root over minus 1 is I, and square root of 16 is 4, so it is 4i. So 9 minus 4 is 5i. Then I to the power 14 is minus 1, and it is minus 5i. Answer is minus 5i. In the form of a plus ib, so we know this 2 plus 2 minus I, if we multiply by its conjugate, we get a real number. So you multiply by the conjugate, 2 minus I, it is 2 plus I, then 3 plus 5i, you multiply by 2 plus I, and this is the simplification. So real part is 1 by 5 and imaginary part is 13 by 5. Then this is the simplification of this. So when there is a fraction, and if denominator is a complex number, we need to make it multiply by the conjugate of the denominator, and we get a real value here, because it is z into z bar is equal to z square, mod z square. So this is a way to simplify this. So this is, we are making a minus a plus ib form, then again we multiply by the conjugate, we get this value. Then Argand diagram we need to draw. So 2 minus 3i, so 2 is real part and imaginary part is 3i. It goes to, so this is real, this is real line, this is real line, and this is imaginary line, this is imaginary. So it is negative part, so it is minus 3. Similarly, minus 5, so it comes from 0, this is 0 0 0, so it is only in this direction. This is 2, this is also complex number. 2 means 2 is 2 plus 0i. Similarly, minus 5i is minus 5i is equal to 0 minus 5i. So this is the way of drawing Argand diagram. In polar form is this. So mod z, you need to find mod z, then arc z, so r is mod z, and this, so r cos theta plus I sin theta. So this is the way of finding this. Then modulus is this, and then modulus, need to find this. Then square root is the way of this. So we have to solve. So if we assume root over z is equal to x plus iy, then x square minus y square, we write the equation, then solve it, and we have the value. This is square root. This is cube root of unity. Just go on simplifying this, then minimize the powers, and we have these values. So very simple thing. And these are some examples you can try to solve.